Assalamu alaikum. My goal in this video is to show you an overview of the RRT exploration package. It's currently supported by ROS Indiego and Kinetic. It may also work on other distribution. You can try it. But before we start, let's explain what exploration is in the first place. So given this scenario, you have a robot which has generated a partial map of the environment, and the goal is to explore the rest of the environment. So if you always drive your robot to the boundary of the known space, like as shown here, this is an occupancy grid, okay, and the white space is the explored and the known area. The gray or green here, it represents the unknown. So if you drive your robot to the boundary of that separates the unknown and the known space, then you will be exploring new areas. So this is the idea behind any exploration algorithm, is to drive your robot towards these points. Like for instance, this is a good point to explore and discover new areas. And these points are called frontier points. So the RRT exploration package does that. It does exploration for single robot and multiple robots. In the multi-robot case, there are other questions like how to coordinate between the robots such that they do not overlap. So let's see all the nodes that the RRT exploration offers. So it has three types of different nodes. The detector nodes, which detect exploration goals or frontier points, and the filter node and the assigner node. And this package has three types of detectors: RRT based frontier detectors, the global and the local one will be explained later in later videos. And also it provides the image processing based detector, which uses OpenCV tools to extract to convert the map into an image and then extract the frontier lines using image processing tools. So we have three types of frontier point detectors. They detect the points in the environment and then they send it to the filter. The filter filters the points and passes them to the assigner. The assigner coordinates between the robots. If you have a single robot, it just tries to minimize the cost. So it command a robot to the nearest location, to the nearest frontier point, and so on. Okay, this is the overall structure for single robot. So if you have a robot, what's required from the robot is that it should be able to receive velocity commands. The robot should have a ROS driver that receives velocity commands, and it should also publishes odometry. Also, the robot driver should also publish the TF on the TF topic. So these are requirements already required from the navigation stack. We need the navigation stack in order to use this package, the RRT exploration. And we need also a laser scanner or any sensor that gives a laser scan topic. Another requirement is the SLAM node, which is the we'll be using the G mapping SLAM node, which takes a laser scan and then publishes the map. Also, it localizes the robot. So what happens is that the map is given to the detectors, the local and global detectors. Also, you can run the OpenCV based detector. So you can run basically any number of detectors, and all of them will be sending the detected points on the same topic to the filter. The filter takes these points and filters them and passes them to the task allocator. By the way, it's not called the task allocator. The node is called the assigner. So the assigner then commands the robot to the target location. So it the target location is sent to the move base node, basically, to the move base node that comes from the navigation stack. It's responsible for driving the robot towards the goal, avoiding the obstacles and everything. Okay, now this is an overview, a more general one, where we have multiple robots. So we have robot 1 until robot n. Okay. This can be chosen using a parameter n robots. Okay, so given that we have n robots, everything will be the same except that there will be an additional component which is a map merger. So the map merger, we need to, for the global detector, which detects the points throughout the global map, it has to be provided with the global map, which is a merge from all the local maps that are obtained from the SLAM G mapping node on each robot. So the global map merger will merge the maps and then give it to the global detector. So the filter also uses this global map as well. So each robot has a SLAM. Each map is used by the local detector and also by the map merger to obtain the global map. Once the global map is obtained, the global detector detects the points in this map. The points that come from the global and the local detectors, they all pass to the filter, which filters them and then passes them again to the robot, to the assigner, which assigns and coordinates between the robots. So if you saw the wiki page, RRT Exploration Wiki page, you will find that there are requirements you have to install, and you have to set up your robot so that it can be so that it can work with this package. So if you are in a hurry and just want to try it very quick, you can do what you can do is you can use the RRT Exploration Tutorials package on GitHub. Inside the package you will find a launch folder, and inside it has all the simulation files, gazebo simulation files needed to bring up a robot. Now it's only added single robot, later on will be added also launch files for multi-robots. So you can just run the launch file and you will have a robot ready and set to be used with the package. Okay, so this is it. I hope you use the package and maybe give me feedback on it, and thank you.